So now we will move on. We will now try to learn the laws of refraction using Huygens principle. See, in refraction there are two possible scenarios. The scenario 1 is that light is traveling from a denser to a rarer medium. Scenario 2 is when light is traveling from a rarer to a denser medium. Okay, so what I'll do is first I'll try to prove it in this case, then we will go to this case. What do you mean by denser medium? A denser medium is one. Suppose velocity of light here is v1, suppose velocity of light here is v2, then v1 is less than v2. What do you mean by rarer medium? If this is v1 and this is v2, then v2 is less than v1. So this is when light is moving from rarer to denser medium. This is when light is moving from denser to rarer medium. Now suppose you have a wavefront here. Suppose you have a wavefront here. This is A, this is B. Now the waves are traveling this way. So the waves are traveling this way. After some time the waves hit this point. Now while the part which is there nearer to A is traveling in medium 1, B enters the new medium. So in the new medium it can travel a greater distance than what this was. Suppose this was v1t. In the new medium it can travel a greater distance. So it will travel v2t. So now this is how the new wavefront looks. So this was the incident wavefront. This is the refracted ray. This is how the refracted ray looks, and this is how the refracted wavefront looks. So if I call this as A, B, I'll call this as A dashed and B dashed. So B dashed is the refracted wavefront, AB is the incident wavefront. This will be V2t, this will be V1t. The angle which the incident wavefront makes with the boundary is what is called as the angle of incidence. The angle which the refracted wavefront makes at the boundary is R, the refracted angle. Now if I apply some, let me look at A dashed B triangle, and let me look at B dashed A dashed triangle. So in this triangle I have sine I is equal to opposite side by hypotenuse. So I'll say it is equal to V1t divided by A dashed B. In this case I can say the sine R is equal to V2t divided by A dashed B. So if this is the case, then what can I say? I can compare these two and say that sine I by sine R is equal to V1 by V2. This is what is Snell's law. So according to Snell's law, sin I by sin R is equal to V1 by V2. Similarly now let me look, I hope you are able to get it. Now suppose I am in this case where there is one medium here, I'll call this as AB, and it is going to another, it is moving from, light is moving from a rarer to a denser medium. So a wave here, it goes and it tries to reach here. In the same time the wave here will be able to travel a much shorter distance. Why? Because B2 is less than V1. So this is how this is the incident wavefront. This will now become the refracted wavefront. By the same logic, if this is I, this will be R. Understand that here the distance traveled is much less than here. So this is how you can prove, or you can show the that sin I by sin R is equal to V1 by V2. So there are two possible cases: light moving from denser to rarer medium, light moving from rarer to denser medium. In both the cases the refracted wavefront will look differently. In this case it appears to be converging at the denser side. In this case also it appears to be converging at the denser side. So whenever light gets refracted at the boundary of at a boundary separating two media, the refracted wavefront will look such that the combination of the refracted wavefront and the incident wavefront appears to converge on the denser side, not on the rarer side. At the rarer side they appear to be diverging, on the denser side they appear to be converging. Okay, so this is what you need to understand.